Try and do this example on your own. We've just gone through it with an example in the previous video, so give this a go on your own and then check that you're correct. So little note you might want to put somewhere, I squared equals j squared equals k squared, which equals 0, and your I, j, k, where clockwise is positive, anti-clockwise is negative. So let's go through and do it. So I've written the two vectors out, and now I just go through and multiply. So 3i times negative 2i is negative 6i squared. So you could just forget about it because you know that that's 0, but I'm just going through and writing it all down. 3i times 3j is plus 9ij. I personally wouldn't recommend working out the positive and negative of the others as you go. I would be writing the step. Okay, it's very easy to make a silly mistake. So the more you write down, the less likely you are to make that mistake. 3i times negative k is minus 3ik. Move on to the next one. I'm going to put on the next line because of room. 2j times negative 2i is minus 4ji. 2i times 3j is plus 6j squared. 2j times negative k is negative 2jk. Finally, negative 4k times negative 2i is plus 8ki. Negative 4k times 3j is minus 12kj. And negative 4k times negative k is plus 4k squared. Okay, so get rid of the zeros. Our positive 9ij will become 9k. Our negative, and it's a negative negative, so positive, and it'll be 3. We've got ik, so it has to be j. Another negative negative, so it'll become positive 4k. Now we have a positive, so negative 2i. 8ki, it's a positive, so it's going to be plus 8j. And then minus becomes a positive 12i. Bring like terms together. Negative 2i plus 12i is 10i. 3j plus 8j is 11j. And 9k plus 4k is plus 13k. Same thing, C times B, do it yourself. You might have noticed a pattern with the 0, positive and negative as well. Okay, hopefully you got that correct. The next part says justify that the vector product from part B, so that was C cross B, is orthogonal to vectors C and B respectively. And orthogonal means at right angles. So that would mean that our dot product would equal 0. So let C cross B equal vector n, and we know that n is equal to 17i plus 11j minus k, which we just found. So we need to show that C dot n is equal to 0 and B dot n is equal to 0. So let's find C dot n first. So C, if it helps you write what C is, so it'll be negative 3 times 17 plus 4 times 11 plus negative 7 times negative 1. Negative 51 plus 44 plus 7, which is 0. Therefore, C is orthogonal to C cross B. Now the dot product with B, it's going to be negative 2 times 17 plus 3 times 11 plus negative 1 times negative 1, negative 34 plus 33 plus 1, which is 0. Therefore, B is orthogonal. Helps if I spell it correctly. To C cross B.